This is part 2 of slopes of parallel lines. In this video, we're going to discuss 3 different examples. And what we want to know is if this equation and this equation, not the equation, but we want to know if these lines, if the line of this equation and the line of this equation, if they're parallel. We also want to know if the line of this equation and this equation are parallel. And I have another example at the bottom. So let's start. For this one over here, remember, how do we determine if two lines are parallel? We look at their slopes. If the slopes are the same, identical, then we can say they are parallel. So this first equation is written in slope-intercept form. It's written in this form. Y is equal to mx plus b. And this is very convenient because I can immediately see that the slope for this equation is equal to -1/2. Now let's check the slope in this equation. Notice this equation is not written in slope-intercept form. How do I know? Because it doesn't look like this. Y is equal to mx plus b. It doesn't look like a y is equal to a number times an x plus a number. It doesn't have this format. That means that this is not written in slope-intercept form. Therefore, I don't know what the slope is for this line. Now, what can we do? Well, we can rewrite this equation to look like the slope-intercept form. So notice slope-intercept form is solved for y. So I'm going to take this equation and solve for y. Let's do that. I'm going to rewrite it. X plus 2y is equal to -4. And then I'm going to solve for y. Here is 2y. So that means I want to isolate this term. I want to isolate it. X is next to it, is being added to 2y. So let's get rid of x. So to get rid of x, here's what you do. You subtract x from this side, and you subtract x from that side, and you are left with 2y on this side equal to -4 minus x. I still have not isolated y. Now I have to divide by 2 so that y is alone. So I divide by 2 on this side, and all of this I divide by 2. And there you have y is equal to -4/2. Remember, we can separate these fractions, minus x/2. So I separated this into two fractions. -4/2 I can simplify. -4/2 is the same thing as -2 because -4 divided by 2 is -2 minus x/2. Okay, now I'm going to rearrange the order of these terms so that the x comes first and the constant term comes last. So this looks like this. Y is equal to -x/2 minus 2. Now, very important here. Very important. Very important. x/2 is the same exact thing as y is equal to -1/2 times x. This is exactly the same expression. Because if you, let me go off to the side here. Let me go off to the side here for a short explanation. When you have 1/2 x, this is equivalent to having 1/2 times x, and you know any number is always over 1. So 1 times x is the same thing as x, and 2 times 1 is the same thing as 2. So you see these are equivalent expressions. 1/2x is the same thing as x/2. So that's how I know that I can rewrite this part of the expression as 1/2x, and since it's negative, then I write -1/2. Okay? Now let's look at this equation. Now it's written in slope-intercept form. right? There's a y equal to an m times an x plus a b. So what is the slope for this equation? Well, I can easily see that m is equal to negative 1/2. That means that the slope for this equation is equal to the slope of this equation. Therefore, I can say that both of these lines are parallel because their slopes are equal. Let's do the second example. In this example, this equation is already in slope-intercept form. That means y is equal to mx plus b. That means m is equal to 3/4. My second equation is not written in slope-intercept form. Nowhere near slope-intercept form, so that means I have to solve for y. Here's y. Here is the y term. I have to isolate it. That means I have to get rid of this negative 3x. That means I want to make this a 0. So how do I do that? Well, I add 3x to each side, and that makes negative 3x plus positive 3x. That makes a 0. On this side, I'm left with 4y is equal to 32 plus 3x. We still have to isolate y, so I have to divide by 4 both sides. Y is equal to, and let's separate these fractions, 32 over 4 plus 3x over 4. We can simplify 32 over 4. What's 32 divided by 4? 8 plus 3x over 4. And now I'm going to rearrange the terms so that the x is first. So 3x over 4 plus 8. There you go. Now this is in slope-intercept form, right? And we can easily see that the slope for this line is 3 over 4. So the slopes are equal. That means that they are parallel lines. Okay? Now, be careful here. I know some of you will be saying, wait a minute, but that's 3x over 4. That's not 4 times x. Let's go off to the side here so I can demonstrate. 3x over 4 is the same thing as 3 over 4 times x. Why? Because x is over 1. So when you multiply numerator times numerator, you get 3x. When you multiply denominator times denominator, you get 4. So it's the same thing if you write 3x over 4 or 3 over 4x, which will be this same thing. And then this will be your slope. Okay? So there you have it. They have the same slope. Our last example, I have y is equal to 3x and y minus 1 is 3 times x plus 2. This equation is written in slope-intercept form, mx plus b, where in this case b is 0 because there's no b, but I do see the slope. Slope is 3. In this example, this is written in point-slope form, in this form. And very easily, I can see that the slope is 3. I have the same slopes. That means that these two lines are parallel. Notice how important it is that you identify in which way these equations are written. You have to look at the equation and know that this is slope-intercept, that this is not, that this is slope-intercept, that this is not, and that this is this is slope-intercept and this is point-slope, because that will help you find the slope very quickly. When you have an equation that's not written in slope-intercept or point-slope, then you have to solve for y. I hope this helps you understand. I'll see you in the next video.